I'm Teacher Lavenda, and today our topic is circles, chords, and tangents. This is a topic in Form 3, Mathematics. So in circles, chords, and tangents, I want us to dwell mainly on tangents to a circle. Tangents to a circle. Let's remind ourselves, what is a tangent? A tangent is a line that cuts at one point in a circle. It cuts at one point of a circle. For example, let us draw. If any case, this is our circle. So we'll say a tangent is a line that cuts at one point of a circle. For example, if this is a circle and a line cuts at this point, let's say that is point A. That is what we call a tangent. And there are several properties of tangents that we have to know before we do calculations. For example, let's say, if this is our circle, I will just have this. If that is our circle, and we have another tangent at this point, so we have two tangents. We say a tangent is a line that cuts at one point of a circle. We have this line, let's say line, for example, let's say line B, this is B, and this is A. And then we have this one to be C. So this is line CA is a tangent, and line BA is also a tangent. We have said now a tangent is a line that cuts at one point of a circle. So you find that when these two tangents, this circle has two tangents, and these two tangents, they are meeting externally outside the circle. There are some properties that we have for that. Properties of a tangent. For example, we know that the first property is line BA. Line BA is equal to line CA. The length of line BA is equal to the length of line CA. That is the first property. The second property, for example, let's say this is the center of the circle. So, this tangent meets at this center, and also this one meets at the center at that point. The angle, let's say there is a line, the center is M, and there is a line that divides the angle that is formed by two tangent lines meeting externally outside the circle. For example, let's draw the line. It is the line. If that's the line. So we have line MA, we have line CA, we have line BA. We have said this line, it bisects the angles. It divides this angle into two, meaning this angle and this angle are equal. The line that divides line MA bisects angle BMC. will be x degrees. So those are some of the properties of tangents that extend outside the circle. Let's do an example. In examples that we are going to do, we are going to use these of our diagram to do examples. For example, we are told, we have this diagram and we have been told this diagram has a radius of 5 centimeters. Because we know from the center to any point of the circle is usually the radius. From the center to any point within the circle is the radius. So let's say in this diagram we have been told that the radius is 5 centimeters. And we've been told the length from M to A. That is the line that is bisecting, angle BMC is 50, is not 50, but the distance from this point is 8 centimeters. So first, I want you to remember this. Any distance from the center to any side of the circle is the radius. And we've been told the radius is how many centimeters? 5 centimeters. So we are being told to calculate the length of the, first we are being told to calculate the length of the major arc, and we are being told the length of the major arc B. Let's say we are told to calculate the length of the major arc, this one, this arc. When we did chords, I think we know how to calculate the length of the major arc. But before we calculate the length of the major arc, we know that the formula for finding to calculate the length of the major arc is length of the major arc is equal to beta over 360 2 pi r. We know this is a right angle triangle. It is a right angle triangle. And this one is going to be our hypotenuse. The line that bisects this angle, that is line MA, is going to be our hypotenuse. So we are going to use trigonometry to solve this. We know that if this is our right angle triangle and this is our hypotenuse, we can use cos theta is equal to, we know that in cos we have adjacent over hypotenuse. And adjacent in this case is 5 over hypotenuse, and our hypotenuse is equal to 13. After that, now we are going to find the cos inverse. When we find the cos inverse of this, we are going to have our theta to be, when we find the cos inverse, we are going to have our theta to be 57.38 degrees. So that is the x. That is the first theta. 57.38 degrees. But we know that what we want is the whole of this. For us to find the whole of this angle, we are going to multiply by 2, because the property said that this angle and this angle, that is angle CMA, is equal to angle BMA. So we are going to multiply this by 2, where now we will get, when we multiply it by 2, we will get 134.76 degrees. BHC. These are. And we have just said the formula for finding the length of a major arc is theta over 360 degrees 2 pi r. So we have this angle. Now we want to get this angle because this angle is what is on the arc that we want. For us to get that, we know that the total sum of angles at a point is 360 degrees. So if this side is 134, for us to get the other side, we will have 360 degrees minus 134.76 degrees. So we will have 360 degrees minus 134.76 degrees. Where we are going to get, when we subtract the two, we are going to get 225.24 degrees. 200, so that is the angle at this point. 225.24 degrees. So that is the angle. Now we have the angle. We have the radius. We can now find what? We can find the arc length. So the formula for finding arc length we have at that point, we are now going to say 225.24 all over 360 times 3.142 times 2 times r, which is 5 centimeters. If we multiply that, we will get our answer as 19.66 centimeter. 19.66 centimeter. That is now the arc length of this part over BHC. That is now the arc length of BHC. So I want us to do another example. Using the same diagram, but now I want to modify a little bit the diagram. I want us to use the same diagram, but now I want it to look a little bit different. So we have, in the figure below, the figure is just here, this figure that we have. Let me just draw a new one. So we have our circle. So we've been told in the figure below, PQ is the tangent to the circle. PQ is the tangent to the circle. Let's draw PQ, that is a tangent to this circle. So at this point we have a tangent. And that is PQ, and that is PQ. That is PQ. Let's say this one is my. This is what is P. This is Q. Is a tangent to a circle at point Q. It is a tangent to a circle at point Q. At point Q. We are told PQ means chord SU, PQ means chord SU, it means from SU proceeding at point P. So we have a chord, and this chord is proceeding to point P. Let's draw it. We know that a chord cuts the circle in 2 points. It cuts a circle at 2 points. So let's say this is the chord. So the chord is SU. The chord is SU. The chord is SU. The chord is SU. We are told QR is the diameter. QR is the diameter of the circle. And we know that the diameter of a circle is just a kind of a chord that divides the circle into 2. So QR is the diameter of a circle. Here is where we had our Q. So it's the diameter of the circle. So that is QR. That is QR, which is the diameter of the circle. We are told O is the center of the circle. O is the center of the circle. And QR meets SU at point C. So this is point C, and then we have the center of the circle at this point to be our O. That is the center. That is the center of the circle. We are told, given that QP is 15 centimeter and UP is 25 centimeter, calculate the length of SU. So we have been given QP is 12 centimeter. QP is not really 12 but 15 centimeter. QP is 15 centimeter and UP is 25 centimeter. UP, the whole of this chord that extends to P is 25 centimeter. Let me just say 25 centimeter. Now we are being asked to calculate the length of SU. Calculate the length of SU. So we want length of SU. The length of SU. This question, that is the length of SU. It is mainly we are going to use the tangent secant theorem. The tangent secant theorem in this case. And the tangent secant theorem, let's write. The tangent secant The tangent secant theorem states that PQ, that is the tangent squared, is equal to the tangent squared is equal to PU or UP, like PU times U times SP times SP. The tangent secant theorem says that QP squared is equals to UP times SP. The tangent secant theorem, it says that PQ or QP, any hand is still correct, is equal to PU times SP. So in that case, after we have known, so the main question or the main thing that we have been asked in this case, or the question requires, do you know the tangent secant theorem? If you know that, the question now will be simple. Let's apply it so that we can now find the value of SU. That is what we want. So we know that QP is 15. It's 15 centimeters square. Is equals to UP. And the question has told us UP is 25. centimeter times, that sign also means multiplication. So times SP. Do we know SP? No, we don't know it. So let's assume SP is X. So times X. Now we can continue. I will have 15 times 15, that is 225. And my square everything. 225 centimeter squared is equal to 25 centimeter X. X is SP. That is what I want. I'll now divide both sides by 25 centimeter by 25 centimeter. These and these will cancel out. Now 25 goes into 225 how many times? It goes there 8 times. 8 times. It goes there not really 8 times but 9 times. So my X will be 9 centimeter. My X will be 9 centimeter. 25 goes into 225 9 times. So after getting this, I have my SP, and that will be my SP is equal to 9 centimeter. SP is equal to 9 centimeter. Since I have SP to be 9 centimeter, and I was told by the question, UP is 25 centimeter, I can now get US or SU. How will I get it? Now SU will be equal to UP minus SP. And then know UP is equal to 25, the whole of that left, centimeter minus 9 centimeter. If I subtract the two, I'll get 16 centimeter. Now US is 16 centimeter. US is 16 centimeter. The next one, we are told, the next question is still on the same. Here is our diagram. If RT, and we know RT is 5 centimeter. RT is 5 centimeter. If RT is 5 centimeter and ST ratio TU is 5 to 3. 5 to 3. So meaning we have been told ST to TU is 5 to 3. If it is 5 to 3, that one will be 5 out of 8. That is the distance from S to T, and then at this point it will be 8. And then at this point we will have 3 out of 8. We know the value, we know the distance from this point to this point, meaning we can now get the exact length. Using the ratios, we can now get the exact length. Let's do that. We will have 5. I will now say 5 out of 8 times 16. That one will give me 10 centimeter. And then 3 out of 8 times 16 centimeter, I will now have 6 centimeter. Meaning, at this point, ST is 10 centimeter and TU is 6 centimeter. Now, the question is, calculate the length of line QT. So, the question that we now want to solve using the same diagram is now length of QT. So the length of QT, we want this distance. This is what we want from QT. That is the question. When we have all the values here. One thing, the relationship between the chords that are inside the circle, that is one thing we are going to use. we have called QR or RQ. So the relationship here is, the relationship that you're supposed to know is line UT times line TS is equal to line RT times line TQ. That is the intersecting chord, the properties of an intersecting chord. So the property says that if you multiply this line and this, it should be equal to this line because they are intersecting. They are intersecting at point T. So we are going to say, we know that RT times TQ is equal to UT times TS times TS. Let's continue now. That will give us 5, that is RT, 5 times X, the part that we have been asked, that is QT. Okay? So times X that we don't have, but it is not just 5, it is 5 centimeter times X is equal to, now we have UT. UT is 6 centimeter times 6 centimeter times TS is 10 centimeter. 10 centimeter. We will have 5 centimeter X is equal to 60 square centimeter. For us now, to find the value of X, we are going to divide both sides by 5 centimeter. Divide both sides by 5 centimeter. X will be equal to 12 centimeter. So that is how we find the value of X. We have used the tangent secant theorem to find the value that we have, that is the SU, and after that we have used the properties of intersecting chords to find the value of QT. I want us now to do this. I want us to do this example as we have a break. I'll draw the diagram. So this is our figure. We have a circle. We have a circle. So we have a circle, and in this diagram we have two intersecting chords. First we have a tangent. We have a tangent, and this tangent, the tangent meets, the tangent is meeting with this chord. It meets with this chord. And then we have at that point, and then we have another chord. We have that. So the question is, in the figure below, we have BT is the tangent. So this is my BT, that is the tangent. BT is the tangent. And we're being told to a circle, HB. We have AXCT. AXCT is a straight line. So we have C, and then we said there is T. AXCT is a straight line, and we are being told, AX is 6 centimeter. AX is 6 centimeter. AX is 6 centimeter, and CT is 8 centimeter. CT is 8 centimeter. CT is 8 centimeter. And we are told BX is 4.8 centimeter. BX is 4.8 centimeter. BX is 4.8 centimeter. The question requires us, we are told XD is 5 centimeter. XD, so this one is our D, is 5 centimeter. Is 5 centimeter. Find the length of XC. So we are told, find the length of X. Find the length of X. Find the length of XC. Find the length of XC. Find the length of XC and BT. XC and BT. I want you to try out that as we have a break. I hope you tried the question out. Now let's do it together. We are told the figure below. In the figure below, in this figure we have AT and we have AX is 6 centimeter, XC we don't have, and then CT is 8 centimeter, BT we don't have, DB is 4.8, and then XD is 5 centimeter. The question requires us to find the length of XC, the length of XC, this one. So for us to find that, we are going to use the properties of intersecting chords. And we say the properties of an intersecting chord is, when we say AX times CX, it should give us the same value as BX DX. So this is what we say. We say, we know that AX times XC is equal to BX times D times XD. AX is 6 centimeter times X is equal to BX. BX is 4.8 centimeter times 5 centimeter. If we multiply 4.8 times 5, we will get 24 squared centimeter is equal to 6 centimeter X. And if we divide both sides by 6 centimeter, we will get X to be 4 centimeter. X is equal to 4 centimeter. The next question was find BT, the length of BT, the length of the tangent. In this case, we are going to use the tangent circuit theorem. And we say in the tangent circuit theorem, In the tangent circle theorem, we said BT squared is equals to TA times CT. Don't forget that. We said the tangent circle theorem says that BT squared, the whole of this square, is equals to TA times CT. The tangent circle theorem says that BT, when we square it, it will be equal to AT times CT. So, we know BT we don't have. So let's assume what we want is X. Let's say it is X. So it will be X squared is equal to, do we have AT? Yes, we have AT. Since we know its value is 4, and we know we have this value and this and this, we can sum it up. 6 plus 4 is 10, 10 plus 8 is 18. So we have 18 centimeter times CT or TC. It's still the same. We will have 8 centimeter. Well now, when we multiply 8 by 18, we are going to have 144 square centimeter. And this one, we know that it is not just X, it is what? It is, we know that it is X, we have said it is X, so we have over X centimeter square. For us to remove the square, we are going to find the square root for both sides. Or let's just say it's going to be square root and square root. When we find the square root of X, we are going to get X. When we find the square root of 144 square centimeter, we will have 12 centimeters. Now, the value of X, that is BT. Now BT is 12 centimeter. BT is 12 centimeter. Now, to try out this example, I want us to try this example. So we have a diagram. I will draw a circle. So we have a circle, and on this circle, we have the tangent. We have a tangent, and the tangent is B, and we have the diameter, that is also a chord, that is A. On this circle we have another chord that has a tangent, and it cuts, that meets with the tangent, and it cuts, this AB is the diameter, and it cuts the diameter at N. Let's say this one is P, and then this point is R. So we've been told PN, that is PN BN, that is BN is 4 centimeter. So we have the tangent is the 7.5 centimeter. So this is the diagram. We are told now to calculate the length of, this is Q. So calculate the length of NR. After that we calculate the length of AN. Calculate the length of NR and AN. Calculate the length of NR and AN. I want you to try out that as we have a break. Come back. I hope you tried out the question. So this one is the diagram. In this case we have a tangent and we have two chords intersecting each other. First let's find NR. That is N and this length. We know that a chord meets at the tangent. This one is the diameter. It meets at the tangent here. At this point of the circle, it forms 90 degrees. It forms a 90 degrees. And if it forms a 90 degrees, this one will be a right angle triangle. And this right angle triangle, we have our hypotenuse as N, R. And we have this side and this side. So meaning we can find the value or the length NR using the Pythagoras theorem. And it states that A squared plus B squared is equals to C squared. A squared plus B squared is equals to C squared. A squared, we have 4 squared plus 7.5 squared is equals to C squared. That is 16 squared plus 56 points. That is 56.25 is equals to C squared. When we add the two, we are going to have, when we add those two, we are going to have 72 points. We are going to have 72.25 is equals to C squared. We find the square root of both sides. When we find C squared, it will be C is equals to 8.5 centimeter. We know the unit was in centimeter. So it will be 8.5 centimeter. And that is my NR. The distance from here to here now, we have found it to be 8.5 centimeter. Don't forget the units. So after that now, I want us now to find AN. For us to find AN, you have to know the tangent circle theorem. And as we had said, the tangent circle theorem, it states that the tangent circle theorem states that when we square A, RB or BR, when we square BR, it will be equal. When we square BR, it will be equal to PR times RQ. When we square BR, it will be equal to PR times RQ. Let's write. We know that BR 7.5 centimeter, we square it, is equals to PR. So we know that from this point to this point is 14 centimeter plus 8.5. That one will give us 22.5 centimeter. So we will have 22.5 centimeter times. Now this value we don't have. Since we don't have it, let's say it is x. So it will be times x. Where now I will have 56.25 centimeters squared is equals to 22.5 centimeter x. For me to find the value of x, I'll divide both sides by 22.5 centimeter. So 22.5 centimeter divided by 22.5 centimeter. So when I cancel it out, I'll find x to be 2.5 centimeter. X will be 2.5 centimeter. So after finding my x to be 2.5 centimeter, that is this point from here, that is QR. That is RQ or QR, RQ is equals to 2.5 centimeter. Now I can easily find the length NQ. I can easily find the length NQ. So NQ will be 8.5 minus centimeter minus 2.5 centimeter. Where now I will find it to be 6 centimeter. That is NQ. The distance from here to here is now 6 centimeter. So from that now, I'll apply the property of intersecting chords. That is, we know that in that case, when we multiply the distance or the length from this point to this point, it should be equal to the length from this point to the other point. Now let's multiply. We know that when we multiply 6 centimeter by 14 centimeter, it should be equal to 4 centimeter by, so because we don't know the value over here, we will say this part to be x by x. And when we multiply 6 by 14, we are going to get 84. Now it will be squared. And we are going to have 4 centimeter x. For us to remain now with x, I'll divide both sides by 4 centimeter. I'll divide both sides by 4 centimeter. Now I can now cancel out. I'll remain with x to be 21 centimeter. So meaning AN is 21 centimeter. So I hope you tried it out, and if any case you missed anything, those are the answers. So the main concept in tangents to a circle is you have to know the tangent circuit. Like in this question, it was just trying to ask us, do we know the tangent circuit theorem? So, and you also have to know that at a tangent, the point where a line passes or cuts a circle, we know